Hey everyone! So in this lesson we're going to be talking a little bit about fractions. So in the past couple of videos we've been talking about things like working with decimals, multiplying and dividing with decimals. So this time around we're going to talk about working with fractions as another way to express numbers that are not complete whole numbers. So we can begin by considering what fractions are. We can think about what does it mean for something to be a fraction. So as I was just saying, fractions can be used to describe pieces of a whole. So just like with decimals and with percentages, we use fractions to describe numbers that are in between whole numbers. Now remember that from our Zoom class that we were talking about how whole numbers are called integers. So hang on, let me write this down. That I could be a little bit taller. Integers. Yeah, sorry about the unclean writing up there, but you know how it is trying to type with a, or trying to write with a touchpad. But yeah, so basically fractions are used to describe pieces of a whole, so numbers between two integers. So if you had like a little number line, so if you drew out something like this, and you've got like 0 over here, and then 1, and then 2, those are integers, those are whole numbers, and everything in between, so everything from right here to right here, can be described using fractions, decimals, percentages. We can also describe the whole numbers using those three as well, but these are the things that we use to describe the numbers that fall sort of in between these whole numbers. So in between 0 and 1, in between 1 and 2, in between 2 and 3, and so on. So so when it comes to talking about different types of fractions, there are of course lots of different ways that we can write them, and lots of different uh, situations that we can be talking about. So here I've just got this little graphic here of describing parts of a pizza using fractions. So this one right here is one whole, so that means that you've got the entire pizza and it hasn't been cut. Over here, this 2 halves means that we've got the pizzas, you still have the entire pizza, as we can see in the picture, but it's been cut into 2 pieces. And then this one down here, this 3/3, is the same thing. We've got the whole pizza, but it's been cut into 3 equal pieces. And that equal pieces is important, that if I have my pizza like this, and I cut it into thirds, but I put one here, well, like I put one cut here and one cut here, that's not, that looks like a computer mouse kind of thing going on, like with the huge buttons. Um, but that's not equal thirds, right? This piece is clearly the biggest, and this one is clearly the smallest. Um, so we have to remember that the pieces need to be equal in size. And then, of course, we've got these different ones here. We've got 2/3, which means that the thirds is telling us that the pizza is cut into 3 pieces. So it's cut into 3 pieces, and we have 2 of them. So we can write it as a fraction like that. And then same deal over here with 1/3. The pizza is cut into 3 pieces, and we have 1 of those. And then lastly, this one up here, 1/2. The pizza is cut into 2 pieces. That's what the half part tells us, and we have 1 of those 2 pieces. So let's look at the anatomy of a fraction. So by that I mean let's look at what the different parts of the fraction mean. So with a fraction like this, it's not really that complicated to understand. Basically, the number at the bottom down here is called the denominator, and the denominator is is responsible for telling you how many pieces make up one whole. So for example, if we look at this first fraction right here, this 1/4, our 1/2, so if we're thinking along the lines of pizzas again, then this denominator is telling us how many pieces make up 1/2. So how many equal pieces make up 1/2. So we could cut it into quarters like this. And the numerator, this top number, that's called the numerator, its job in all three of these cases, the job of the numerator is to tell us how many of those pieces of the whole we already have. So in the case of this first fraction again, in the case of this 1/4, the denominator tells us that the whole is cut into 4 pieces, and the numerator, that 1 up top, is telling us that we have 1 piece. So we could sort of shade in 1/4 of our pizza here. We shade in one of the 4 pieces, and that's 1/4. For 2/3, the second one, this one right here, it's a similar idea. We've got our pizza like this, and we cut it into thirds. This might not look equal, but I'm doing my best. So we cut it into thirds like so, and we have 2 of those pieces, so we can shade in 2 of the slices like so. So there's 1 piece that we have, and here's the second. So we've got 2/3 of the, oops, that wasn't supposed to go there. Okay, yeah, so shade in this right here, and there we can see that we've got 2/3 of the pizza, and this last third is the one that we're missing. And for this last one, same kind of idea. You've got your pizza, and it's divided into 7. So this is going to be a little bit ugly to try and draw, but maybe something like this, and then like this. 1, 2, 3. Got 4. Have I got too many? 4, 5, 6. Whoops. Okay, I've sort of drawn this wrong. Let's try that again. Okay, if we try this again. I was going to end up with 9, I think. So let's try and make those pieces a little bit bigger. So suppose we've got something like this, and then we break this up here, and here, and here, and here. Is that 7? 1, 2, 3, 4, 5, 6, 7. Looks like 7 to me. Of course, they're not perfectly equal, but yeah, I'm trying to freehand this. And then we've got 5 of those. So I wonder if this will color it in more efficiently. Excellent. Okay, so we've got 5 pieces. So there's 1, there's 2, there's 3, there's 4, and there's 5 right in there. There we go. So we've got 5/7 of the pizza that way. So in this way, we can see how the numerator and the denominator work and what they actually mean. And it really helps to draw pictures to try and understand what the fraction is telling us. So there are 3 different types of fractions. The first type is a proper fraction. That's this one up here. And what that means is that the numerator, the top number, so hang on, let me write these words out once because I'm feeling uneasy the more I say them without writing them down. So we've got the numerator, that's the number on the top. And for a proper fraction, the numerator is smaller than the number on the bottom, which is the denominator. So I'm going to write that down in a second as well. So we've got the numerator on top, and we've got the denominator on the bottom. D-E-N-O-M. Good Lord, trying to write with this is hard. But, okay. Denominator. Okay, so for proper fractions, the numerator is smaller than the denominator. So we can see that in the first example over here, we've got 4/7. So the 4 on top is smaller than the 7 on the bottom. In the second example, we've got 8/9. So same thing, the 8 is smaller than the 9, so it's a proper fraction. Here we've got 1/2, the 1 is smaller than the 2, 3/13, the 3 is smaller than the 13, and 99 hundredths. So the 99 is smaller than the 100. So there we go. That's what makes a fraction a proper fraction. The second type is an improper fraction, which basically is the exact opposite in that the numerator is larger than the denominator. The number on top is bigger than the number on the bottom. And we can see that in each of these examples here. So we've got 14/3, that means the 14 is bigger than the 3. We've got 5/2, so the 5 is bigger than the 2. 3/1, we're going to come back to this a little bit later, but if you've got a denominator of 1, that means you're basically working with a whole number. So if this is telling you that you only need one piece to make up the whole. So for example, for a pizza, that simply means that you haven't cut the pizza. So if you've got 3 uncut pizzas, that just means 3 pizzas. So having a denominator of 1 means that this whole fraction right here, this 3/1, is actually just equal to 3, because the denominator of 1 doesn't change anything. So yeah, so we get that this is an improper fraction the way it's written, though, because the 3 on top is bigger than the 1 on the bottom. Same thing over here, 43/19. The 43 is bigger than the 19. And over here we've got 199 hundredths. The 199 is bigger than the 100. And the third type of fraction is a mixed number. And the way this works is basically you have a whole number and then a proper fraction that's a little bit extra. So the way improper fractions and mixed numbers work is that they describe fractional numbers, so numbers that are not integers, that are bigger than 1. So for example, let's look in the case of this 5/2 here for improper fractions. Suppose we've got a pizza and we cut it in half. It's quite easy to draw that. Looks something like this. That's one pizza cut into 2. But if we only have the one pizza and I and I color it in like this, if we've only got the one pizza colored in like so and like so, then that means that we've only got 2 halves. So that's not good enough. So we need to draw in a second pizza. Whoops, I haven't changed the color, but whatever. So we have to draw in a second pizza. I'll draw the line in black at least. Like so. We draw the second pizza, and now we need to color in more pieces here. I think this is what's going on with the colors? This is a slightly different color maybe. Whatever. So we color in this half here and this half here, and that gives us a total of 4 halves, right? So we've got, if we count the halves that we have so far, we've got 1, 2, 3, 4 halves of the pizza, but we need 5 halves. So we have to draw in one more pizza. So we draw that in over here. And we cut it in 2 because we're dealing with halves. And we color in just one more because we need to have 5 halves in total. So we color in this half here. And so this tells us that we've got our 5 halves of the pizza. So this is how it looks when you try to draw it out. It's that you have multiple complete pizzas, right? These first 2 pizzas are complete pizzas. They've just been cut down the middle, but nobody's eaten any of it. So this is a whole pizza on the left, a whole pizza in the middle, and then half a pizza on the right, this one over here. With mixed numbers, it's the same idea. So let's take this as an example. It's a slightly different example. So we've got 1.5 pizzas, and this one's maybe a little bit easier to work with. The number on the left, the big whole number on the left, tells you how many whole pizzas you have. So we don't even have to cut it. We just know we have one complete, that's an awful circle, but no, I'm not happy with that. So we know we have one complete pizza, and we know that we have like the entire thing. So I can, without bothering to draw in any cuts and stuff, we know that we have one entire pizza like so. And then we know from the second part here, from this fractional part, that we have an additional half a pizza. So I can draw in another pizza and we can cut that in half. And then we've got half of this one here. So we can draw it in like this, just to see, visually, what does this look like? And what we find is that this 1.5 here looks like this. So we've got one complete pizza. If you wanted to draw the cut in just so that it looks more like the example above, you can do that. But basically we've got one entire pizza, that one on the left, and then we've got half a pizza, which is the extra bit on the right. Now, when it comes to working with negative fractions, you can absolutely write negative fractions and work with negative fractions. The three ways that I've written it on screen right now are all exactly the same. So if you've got a negative fraction, writing a negative on top, as we've done in the case on the left in this one, writing the negative on top is the exact same thing as writing a negative on the bottom, and that's exactly the same thing as writing the negative sign just out in front of the rest of the fraction. So you're totally allowed to write it any one of those three ways. Just be careful, because if you're trying to write a negative fraction and you write it with a negative both on top and on the bottom, those negatives actually cancel out, because it's basically -1 divided by -1. Like if you ignore the numbers, this negative sign and this negative sign cancel each other out, so it's actually equal to 1/4. So just be careful when you're working with negative fractions, or if I ask you to write the negative version of a fraction, don't put a negative sign both on the top and the bottom, or basically don't put two negative signs. So if you have a negative sign on the top, that's fine. You don't need to add one on the outside of the fraction like we saw over here. You don't need to add it on the bottom like we saw over here, etc. So you just need one negative sign somewhere in the fraction to indicate that it's negative. And if you have two negative signs, then it's actually a positive number. So recall from what we were talking about a couple of minutes ago, improper fractions and mixed numbers are actually trying to communicate the same idea. They're trying to communicate a non-whole number. They're trying to communicate some sort of fractional number that's bigger than 1. And they're both trying to do exactly the same thing, which means that we should be able to write an improper fraction as a mixed number, and we should be able to write a mixed number as an improper fraction. So we're going to do a couple of examples of this in a second, but first I'll just let you read through this and I'll read it out, what I've written down there. So the process by which you convert an improper fraction to a mixed number is long division. So we use long division to determine the mixed number form of an improper fraction. I've got a couple of examples that I stole from Google, and then we'll actually work through one as well, so that you can see how it works. So when you go through the long division process, the quotient, the number that you end up writing on top of your long division problem, is the number of wholes that you have, the number of whole numbers that you can make out of your improper fraction. The remainder tells you the new numerator. It tells you how many leftover pieces you have once you've made as many wholes as you possibly can. So the remainder of your problem, without trying to go into all the decimal stuff, the remainder tells you your new numerator, and the denominator just stays the same. You still have if your pizzas were cut into quarters before, they're still cut into quarters now. You're just expressing the wholes a different way. And for converting a mixed number to an improper fraction, we use this process where we multiply the denominator by the whole number. So if we take the denominator and we multiply it by the whole number, that tells you the number of pieces that make up those complete wholes. So I'll throw a quick example down here. So So if we had like 2 1/4 and we wanted to write this as an improper fraction, then we know that this can be drawn out as, well, we've got our 2, and then we've got 1/4, like so, right? We've got 2 1/4 like that. But these two wholes could also be cut into quarters. As long as we still have all 4 pieces, it's still 2 wholes, right? But now if I want to count how many pieces I have in total across these 2 wholes right here, then I can take the number of pieces per whole, per pizza, which is this 4 right here, and I can multiply it by the number of pizzas, which is 1, 2. So we multiply this denominator by this whole number, and that tells us how many pieces we have in just the complete pizzas. But then we have this little guy left over, this little extra one that didn't make up a whole at the beginning, so we add that one on. So we start going from the denominator to the whole number, we multiply those together, so I can put in just like as a little graphic, we put in this little multiplication sign, and then once we're done that, we add on the whole number, so I'll put a little plus sign there. So we start with this denominator, we multiply it by the whole number, that tells us how many pieces we have in the complete pizzas, and then we add on the extra slice that's left over. So here's an example, just a couple of examples in fact, of converting an improper fraction to a mixed number. So what we've got in this example on the left here is we've got 7/4 as the improper fraction. So we write it out as a long division problem. Here's the 7, here's the 4. So we write it out like that, 7 divided by 4. The numerator basically goes inside. The numerator from this improper fraction goes inside the fraction, and the denominator becomes your new divisor. It's the number you're dividing by. So if we go through the long division process, 4 goes into 7 one time, so we write the 1 up top. 4 times 1 is 4, so we subtract that down here. 4 times 1 is 4. 7 minus 4 is 3. And this 3 is our remainder, right? So that's our remainder there. So when we write it out as a mixed number, our whole number is our quotient up top. That told us how many complete pieces we were able to make. So that's this 1 right here. The remainder becomes our new numerator, as we can see right there, and the denominator just comes along for the ride. So this 4 is the same as this 4 right there. And here's a second example, which you can look at. It works in a really similar way. 28 divided by 5. The 28 goes in here. That's our new dividend. The 5 comes along on the outside. That's what we're dividing by. And then dividing, doing the long division, we get how many times does 5 go into 28? It goes 5 times, so we write the 5 up top. 5 times 5 is 25, so that's where it comes down here. We do that subtraction, we're left with 3. And that 3 is our remainder because it's smaller than 5. So that remainder goes on to become our new numerator down here. Our whole number, that quotient, that 5, comes down here, and the original denominator from the problem, this original 5 right here, comes down and is still our new denominator. So that's how that works. So now we're going to go through a couple of examples. I think I have 3 examples in total. And what we're going to do here is we're going to express a couple of improper fractions as mixed numbers and a couple of mixed numbers as improper fractions. I don't remember. I think I've got 3 examples. There's 2 going one way and 1 going the other way. Like 2 going from improper to mixed and 1 going from mixed to improper, something like that. So let's get started. So let's do this in red because why not? So we want to express 14/3 as a mixed number. So we're dealing with this fraction right here. It's 14/3. So going from an improper fraction to a mixed number, we use long division. So if I do that, I can write out my 14 like this. we can write in our division sign and stick the 3 out here. So if we do this division, how many times does 3 go into 1? Well, it doesn't, so we can just ignore that. And then we re-ask ourselves, how many times does 3 go into 14? 3 goes into 14 4 times, right? 3, 6, 9, 12. So we can put a 4 up top. Now 3 times 4, if we multiply those together, 3 times 4 is 12. So that's what goes down here. And we subtract, right? And 14 minus 12, that's going to leave us with 2. Now since 2 is smaller than our divisor, our 3 up here, that tells us that this 2 is our remainder. So we can write in a little r if you want a reminder that it's your remainder, draw in a little r. So now we just need to collect the pieces and build our mixed number. Now we know that the quotient tells us how many wholes we have. So this 4 up here tells us how many wholes we have. So our mixed number is going to have a big 4 sitting out in front. And then it's going to have a fraction. And we know that the denominator of the fraction just comes along for the ride. So this 3 comes along for the ride and sits right there. And then the last step is we take our remainder from our long division problem, and that becomes our new numerator. So that comes along over here, and we get the 2 up there. And so this is our mixed fraction, or our mixed number, for the improper fraction 14/3. And if you wanted to double check, you can always go back in the other direction. So going from a mixed number to an improper fraction, you can start with this denominator, multiply it by the whole number, and then add the numerator. So if we start with that, we do 3 times 4, denominator times the whole number, that's 3 times 4 is 12, plus 2, that's 14, and that becomes your new numerator for the improper fraction. So if you went through the conversion the other way, going from mixed to improper, you should wind up with the same thing that we started with, so you know you've done it right. So in this example, we're going to go the other way. We're going to go in the other direction. We're going to take the mixed number, 2 and 4/7, and convert it into an improper fraction. So we're going to follow the same process. I'm going to sort of write it a little bit more spaced out just so we can see what's going on. We've got 2 and 4/7. And the process, if you remember, is we start with this denominator, and then we basically go clockwise around. So we go this way, denominator times the whole number, and then add the numerator, and that becomes your new numerator in your improper fraction. So when I go to write out my improper fraction, the denominator is going to stay the same as what I had originally, because no matter what, no matter how many pizzas I have, everything is cut into 7 slices. So I'm going to have a 7 as my denominator no matter what. But to figure out the new numerator, we have to go through this process. So first we go around, we do 7 times 2, that's 14. So we get a 14 up here. But then we have to add on the new, we have to add on this leftover numerator. So we did 7 times 2, that's 14. Now we have to do this addition. 14 plus 4 is 18. So we just need to add on this 4 right here. So I'm writing this in a couple steps. So we get 14 plus 4. So we know 14 plus 4 is 18. So we can write this out as 18 over 7. And that's our improper fraction. And I'll leave it up to you guys if you feel like you could use the practice. Try going in the other direction. Try doing the long division and see if it gives you the same answer as the mixed number that we started with, this 2 and 4/7 that we had at the top. But yeah, this 18 over 7, whoops, this 18 over 7 right here is your answer. And lastly, here is our third example. We want to now express 145 twelfths, or 145 over 12, as a mixed number. So once again, we're working with an improper fraction going to a mixed number, so we have to do this using long division. So we take our numerator, and that becomes our new dividend. So 145 we can write like this. Then we can put our division sign like so, and then we put a 12 over here. And we ask ourselves, how many times does 12 go into 1? It doesn't, so we can ignore that. And we move on to how many times does 12 go into 14? And 12 goes into 14 once, so we can write a 1 up top. 12 times 1 is 12, so we subtract 12 down here. And that leaves us with 2. Now this isn't our remainder because we're not done the long division problem yet. Now we have to bring down this 5, so we get a 5 down here. So now we've got a 25 down here. Now we do the same long division process again. How many times does 12 go into 25? And we get that 12 goes into 25 twice. 12 times 2 is 24, so we do this 12 times 2 is equal to 24. That's what goes down here. If I'm going too fast with the long division, let me know the next time we all talk, and try to check out the videos I made last year about this stuff, because I think I went about it a lot slower there. And it'll help you a lot. The more you practice your long division to get up to speed, it'll help you a lot down the road. So anyway, continuing with this, we now have a subtraction problem. 25 minus 24 is 1. And since we've run out of numbers up here in our dividend, we don't need to go into making it decimals and stuff. So we can simply say that this 1 down here is our remainder. And this means that we are just about done and we can build our mixed number using this. So to build our mixed number, the quotient, our answer that we got up here, is our new whole number. This tells us how many wholes we can make out of the 145 slices. So we've got 12 wholes, and then we've got some fraction. Now we know the denominator of the fraction is going to be the same thing as what we were dividing by, and the same thing as our original denominator, so we get that this 12 just carries over down here. And then our new numerator is just this remainder from our long division problem. So if we take that remainder and we go around, we get that this is a 1 up top. And if you wanted to check your final answer, you could go the other way around. You could take this mixed number, 12 and a half, or no, not 12 and a half, 12 and 1/12, and convert it back to an improper fraction. So if you do 12 times 12, you'll get 144, plus 1 is 145. So that should give you your new numerator, which is this 145 up here. So we can be pretty confident that we've gone about this the right way. Now, I touched on this a little bit before, but we get a little bit of a special case when the denominator of the fraction is 1. So a fraction with a denominator of 1 is basically telling us that the whole is made out of one piece. So we get that the entire pizza has not been cut. The entire pizza is just a circle with all the toppings, and it's not cut into any number of slices. So the entire pizza is just 1, and the denominator is 1. Now, if you have 3 uncut pizzas, that means you just have 3 whole pizzas, right? If your entire, like if you said I have 3 pieces of a pizza, but the piece is the entire pizza, then you don't have 3 pieces, you have 3 whole pizzas, right? So this like we know that ordinarily your numerator tells you how many pieces you have, but if your piece is the entire pizza or the entire pie or the entire whatever, then the numerator is simply telling you how many wholes you have. So if you have a fraction with a denominator of 1, that's basically just a number. If you've got 3 over 1, that's telling you that one piece makes up one whole, and you've got 3 pieces, so you've got 3 wholes. So you can write that as simply the number 3. So that's what we've got in these few examples down here. 4 over 1 is equal to 4. You can also think of it as dividing the numerator by the denominator. So that's what I've written right here. You can think of it as dividing the numerator by the denominator. So 4 divided by 1 is still 4. It doesn't change anything. 7 divided by 1 doesn't change anything. So it's still, you're still going to get 7 as your answer. Negative 2 over 1, this can be a little bit tricky because the idea of the pizza thing kind of breaks down. So we can make use of the fact that we can rewrite this by sticking the negative sign on top. So we're dealing with a negative 2 and we're dividing that by 1. Dividing by 1 never changes your answer. So negative 2 divided by 1 is still negative 2. And if you have 1 and you divide it by 1, that's still 1. So same deal here. So that process holds for any of these cases. And this is sort of the last thing I want to talk about today, is that if both your numerator and denominator in your answer of your fraction, whether it's a proper fraction, an improper fraction, or a mixed number, you can have that your numerator and denominator are both multiples of some number, then you can divide both of them, the numerator and the denominator, by whatever that number is that they're both a multiple of, and the fraction means the same thing. So what I mean by that is, if you look at this example here, we've got 8/64ths, but your keen eye may have recognized that both of these are multiples of 8. So we can rewrite this as 8 times 1, that's the 8 on top, and 64 is 8 times 8. So what we can see here is that we've got this common, there's one 8 on top and one 8 that we can pair it with on the bottom. We can't pair this 8 on top with both 8s on the bottom, but we can pair it like this and cancel that out. If we can make a pair with a number on the top and one number on the bottom, we can cancel them out, which just leaves us with this 1 over 8 left over, and that's this answer right here. In the second example, we've got 34/4, which, suppose the question was to write it as a mixed number, then you can go through that process. We can write it out like so. We can write it out as 8 2/4 because the denominator stays the same and all that. But then you might notice that this 2/4, both numbers are multiples of 2. So you can rewrite it like this. You can rewrite the numerator as 2 times 1 and the denominator as 2 times 2. And then you can pair off one of the 2's on top with one of the 2's on the bottom and cancel them out, which means that we're just left with, in our fraction, we're just left with this 1/2, and the whole number stays the same. The whole number doesn't have to get bothered at all. So we get 8.5 as our final answer here. If you went the other way and suppose it was just reduce this improper fraction that you started with, you could have reduced it first and then gone about making it a mixed number, or maybe the question was just to reduce it. Then we can notice that both of those numbers, the 34 and the 4, are multiples of 2. 34 is the same as 17 times 2. And the 4 is, of course, 2 times 2. So we can pair off this 2 with this 2 and cancel them out. That's gone, that's gone. And we're left with 17 over 2. And then if you wanted, or if the question was asking for a mixed number, you're totally allowed to, reduce first if you think it'll make it easier, because now we're working with smaller numbers. We're not working with anything bigger than a 20, whereas before we'd have been working with a 34. So you're allowed to reduce first, and then if you convert this into a mixed number, if you go ahead and you do the long division, you'll get this same answer over here. You'll get the same 8.5. So if you're not sure of how to get that, try it out. Try doing the long division and see if it spits out 8.5. And if it doesn't, then let me know either in a comment or the next time that we all see each other, and we will talk about how this stuff works. So I kept this final slide here just in case I felt I'd missed something, because when I was making this lesson it was quite late at night, so I thought maybe there's a point I've missed that I'll remember when I'm recording, but I think I covered my bases pretty well. If you guys do have any questions, absolutely feel free to let me know. If you feel like I've gone too fast through the long division or something, then let me know and we can talk about that. I was trying to make sure I didn't take too long to do the simple stuff that wasn't directly related to the fractions, because this video is already 41 minutes long. But yeah, so if you felt that was a bit too fast, then let me know and I can try and adjust that for next time. If there's anything that's confusing you, let me know. Send me an email. Let me know on the Google Classroom or the next time that we all see each other. Otherwise, I'll see you all in the next video. Have a good one.